let us first understand the purpose of improvement techniques of lean. We have seen earlier that in order to improve any process, we need to first do the value stream mapping. By doing value stream mapping, we identify the 7 types of waste in the process, and we get the insight into why the delays are happening. So, value stream mapping helps us to effectively analyze the process. And by applying various improvement techniques of lean, we try to eliminate the waste, reduce the delays, and optimize the process. In other words, improvement techniques of lean help us optimize the process.
Now we will see 5S. In Japanese language, these are the 5S. As translated into English, they are sort, set in order, shine, standardize, and sustain. The 5S technique focuses on properly organizing the materials and information so that we can reduce some of the 7 types of waste in a given process. Here are the definitions of 5S. The first S is sort. Sort implies sorting out or removing unwanted items and keep only what is required. When we sort the materials properly, we reduce transportation, inventory, motion, and waiting waste. The next S is set in order. It implies that we need to set the things in order by placing the right items at the right places with labels, display boards, etc. When we set the items in order, we reduce transportation, motion, and waiting waste. The next S is shine. It implies that we need to keep the items shining by always keeping them clean and in working condition. When we do this, we reduce transportation, motion, waiting, and defects waste. The next S is standardize. This tells us to standardize the procedures and practices of processes. In other words, we need to have standard operating procedures for all the processes. By standardizing the processes, we reduce transportation, motion, waiting, and defects waste. And the 5th S is sustain. This implies that we need to continuously practice all the above 4 S for sustained orderliness of processes.
Now, let us have a look at how 5S is being practiced in various industries. Let us first consider the restaurant industry. You may observe how the food items, supplies, utensils, and other items are placed so conveniently and orderly in restaurants. We can say that the following principles of 5S are followed in restaurants: sort, set in order, shine, and standardize. And we see that transportation, motion, and defects are minimal. For example, at Subway, a sandwich artist keeps all supplies that are placed neatly organized, and while making a sandwich, she doesn't need to move to multiple places. And in buffet restaurants, we see all the food items are sorted and set in order. For example, all the desserts are arranged in one place. "5S at pharmacy. At a pharmacy store, we see how the drugs are clearly sorted and kept in order. For example, some drugs are kept in alphabetical order, some are arranged according to their usage against a particular symptom, etc. And we see that transportation, motion, waiting, and defects are minimal for the pharmacists. "5S on smartphones. On our smartphones, we see how the apps, menus, and the navigation screens are organized according to their category and functionality, and we see that transportation, waiting, and defects are minimal for the users of smartphones.
Let us look at another example of how 5S can be applied at a bank. Let's say the issue is cycle time of loan processing is high. When we did the value stream mapping, let's say we observed the following reasons for the delay in processing of loans. Customers need to fill multiple forms at multiple desks to apply for a loan. This clearly causes motion, overprocessing, and waiting waste. And the loan applications are sent to different floors of the building for multiple checks. This clearly causes transportation, overprocessing, and waiting waste. By applying 5S techniques, we've found the following solutions. Let us consolidate and reduce the number of forms and the information that needs to be filled by the customer and reduce the number of checks. And let us reorganize the workspaces such that all the loan processing team members work on the same floor. These actions will clearly reduce the types of waste that are mentioned above.
Now let us see how we can make 5S effective in 21st century. As we are aware, we have physical infrastructure and the digital infrastructure. At the physical infrastructure level, we can apply 5S technique to maintain orderliness of our materials, tools, equipment, files, documents, supplies, and so on. And at the digital infrastructure level, we can apply 5S technique to properly organize our applications, emails, folder structures on our computers, and the way we compile our status reports, and so on. Let's understand Tact Time. Tact time is the maximum allowed time that a service or a product needs to be produced to satisfy the customer demand. Here's the formula for tact time. Tact time is equal to the available working time divided by required units of production. Now, using the same example, let us understand why this tact time is very important. As we have calculated, the tact time is 4.2 minutes. Let's say the overall process has 4 sub-process steps. The sub-process step 1 has a cycle time of 4 minutes. The process step 2 has a cycle time of 3 minutes. The third one has a cycle time of 6 minutes. And the last process step has a cycle time of 2 minutes. As we know, the first process step takes the input. It gets processed over these 4 process steps, and finally, the finished unit comes out from the last process step. Let's understand what the lead time of a process is. For this process, the overall processing lead time is 4 plus 3 plus 6 plus 2, which is equal to 15 minutes. Does this mean every unit takes 15 minutes to produce? If this is the case, we will not meet the target of 4.2 minutes tact time. Let us have a more detailed view on how much time each unit takes for production. So far, we have completed the following improvement techniques of Lean: Kaizen, 5S, Kanban, Visual Control, Poka-yoke, and the workload balancing using Tact Time. In this session, we will see the remaining improvement techniques, which are as follows: Heijunka, Jidoka, Andin, Gemba Walk, Just in Time, and Toyota Production System.
Let us now understand just-in-time concept. Just-in-time concept advocates producing only those quantities of units as ordered by the customer using the pull mechanism and Kanban. A just-in-time process reduces the inventory and overproduction costs and waste. To make just-in-time work effectively, the entire supply chain value stream need to be in sync with the just-in-time requirements. In a just-in-time system, if there are any delays in supply chain, it will adversely impact the deliveries and, in turn, the business. Usually, a combination of push-pull system is more practical for many industries. Let us understand the push system in a little bit more detail. push system is also called make-to-stock system. The push system advocates making the production of certain volume of units based on a forecast, not based on the actual customer orders. A push system is recommended when a process has any of the following characteristics. The process has long lead times, for example, agricultural products like rice, etc. A low-capacity process, for example, a machine is available for only 1 hour in a day. A process that has low output variety, for example, commodities like coffee beans. A process with low cost of finished goods, for example, nails, nuts, bolts, etc. In such cases, a push system is recommended because it will help prevent shortages.
Let us understand the pull system in a little bit more detail. A pull system is also called make-to-order system. A pull system advocates making the production of exact quantities of units according to customer orders. A pull system is recommended when a process has any of the following characteristics. A process that has short lead times, for example, fast food restaurants. A process that has high capacity, for example, printing machines. A process that has high output variety, for example, interior designs. A process that has high cost of finished goods, for example, ships, airplanes, etc. In reality, many industries follow a hybrid model of push-pull systems, for example, PC manufacturers.